So the next thing we're going to bring about number bases that have decimals, or that have decimals or have fractions. Okay, number bases with fractions. For instance, if I have 572.43 in base 10, what does this actually mean? Okay, so you remember the last time I told you you're going to start writing the 0, 1, 2, 3, and you're going to be going upstairs. So in this case, look at where the point is. This is where the point is. Okay, this is where you're going to start writing your 0 from. This is your 0, this is your 1, and this is your 2. This is not where you're going to start writing your 0 from, because this is where the point is. This side is the fraction part of the number. So your 0 starts from the unit, the last digit before the decimal point. The last digit before the decimal point. That's where you start labeling your 0, and then you start moving 1, 2, and start moving upwards. Now, as you do that, on this other side, which is the decimal or the fraction side, you now go as -1 and -2. So if it continues to go further, that's how you keep on going, -3, -4, -5. Remember, here is 0, 1, 2, and you move upwards. Why from the decimal points is not 0, it is -1 that starts first, -2, then -3, and so on and so forth. So after labeling like this, we can now tell ourselves what the original values of these 5, 7, 2, 4, 3 as digits, what are their real values in terms of counting in base 10. So I believe you can join me as we do this. So for 5, it's going to be 5 times 10 raised to the power 2, plus for 7, it's going to be 7 times 10 raised to the power 1, plus for 2, it's going to be 2 times 10 raised to the power 0, then plus for 4, it's going to be 4 times 10 raised to the power -1. Then for this 3, it's going to be plus 3 times 10 raised to the power -2. So 5 times 10 raised to the power 2, 7 times 10 raised to the power 1, 2 times 10 raised to the power 0, 4 times 10 raised to the power -1, 3 times 10 raised to the power -2. So having done all this, we can now break it down. For this one, you have 5 times 100. 10 times 10 is 100, so it's going to be 500. This one is 70. This one is 2 times 10 raised to the power 0. 10 raised to the power 0 is 1, so it's just 2 times 1, 2. Plus, now, anytime you have a number, sorry, I'm going to be delving into this a little bit. So if you have, let's say, a raised to the power -b, and you want this minus in this power to disappear, you can just say 1 over. Once you just say 1 over, the person goes down, the a goes down. When the a goes down, the minus sign disappears, and then only the b exists. If you bring it back up, the negative sign also appears back. So the same principle is what I'm applying here. 10 raised to the power -1, the 10 goes down and the minus sign disappears, and I only have 1 there, and it becomes 4 times 1 over 10 raised to the power 1. Then plus, you have 3 times, you do the same thing here. Can we make the 10 go down? Yes, it becomes 1 over, bring the 10 down. What happens? The negative sign disappears, and we have our 2. So with this, we now have 500 plus 70 plus 2 plus, now 4 times 1 over 10. 10 raised to the power 1 is 10. So that's 1 over 10. 4 times 1 over is going to give you 4 over 10. 3 times 1 over 10 raised to the power 2. This 10 raised to the power 2 you're seeing here is 10 times 10. That will give you 100. That's 1 over 100. 1 over 100. So you're going to have 3 over what? 100. So the original value of this 5 is 500. The original value of this 7, 70. Original value of this 2, 2 units. Original value of this 4, 4 tenths. Like this. Original value of this 3, 3 hundredths. That's, you put 100, but you put th. So basically, this is how you expand a number in base 10. And I've used that opportunity to also show you the original values of each of the digits in this number.
Thank you for watching. Please subscribe to our YouTube channel.